In this video, I'm planning to explain infinity over infinity as a limit. Now, there are two polynomial functions. When you apply the infinity to the power of n is going to be infinity to the power of n is going to be equal to infinity again. When you multiply infinity by itself, infinity it's going to be. So this is going to be down, up is infinity, down is infinity. The method that we are applying here to get the parentheses, x to the power of n parentheses and x to the power of n parentheses, like x to the power of 5 plus x to the power of 4 plus x to the power of 3 plus x to the power of 2 plus x to the power of 1 and 1. If I try to get this expression into x to the power of 5 parentheses, then this one is going to be equal to 1 here. This is going to be 1, but x to the power of 4, we don't have x to the power of 5 inside the x to the power of 4. That's why it should be equal to 1 over x. Then 1 in x to the power of 3, normally we have x to the power of 3 here. 2 more x square we need. That's why we are writing that one to down. 1 over x square it becomes. And x square, normally we need 5x, 5 times. Pardon, x times x times x, 5 times we are going to multiply. We have only 2 of them here, that's why it's going to be equal to 1 over x cubed. As you see, we are subtracting the power. Let's say here it is 5, when you subtract 2, the result is 3. It's going to be like that. And when you have the polynomial function and you have the greatest power here, these expressions, what is written here, as you see, when you apply the infinity to the denominator, 1 over infinity is going to be equal to 0. 1 over infinity square also 0, 0, 0. It's going to continue like that. Okay, then it says this is the last step now. Here, when you get x to the power of n parentheses, you are going to leave only a and x to the power of n for the infinity, x tends to infinity case. This is only possible. A n x to the power of n. We have 3 possible cases here. 3 possible cases shown here. If n is equal to m, n is less than m, n is greater than m. If n is greater than m, an over bm. If these 2 powers, they are equal to each other, the coefficients you are going to take. If n is less than m, it means that this is equal to 0. If n is greater than m, this numerator, if numerator's power greater than denominator's power, the result is going to be plus or minus infinity with respect to given information. Here there are polynomial functions. That's why it's easy to solve these questions by using the property. That's why directly I'm going to use the property n is equal to 3, m is equal to 3, n is equal to m case. So the answer is limit is equal to a over b case. What is a over b here? That's equal to 5 over. That's equal to 5 over 4. The second one, n is equal to 3, m is equal to 5, n is less than m. It means that the answer is 0, because in that case the limit was n is less than m. Result is going to be equal to 0. But this is possible only for polynomial functions. For the functions, radical expressions includes the radical expressions. As you see, this is not possible. Now I have here 2x plus 4 over root of x squared plus 2. Now for the numerator, it's easy to get x parentheses. When you get x parentheses, limit x tends to infinity. X parentheses I got 2 plus 4 over x, it's going to be, because I don't have x here, that's why 4 over x. When you get x parentheses, this should be 4 over x. Down is x squared in the root of x squared times 9 plus 2 over x squared. When you get x squared from 2, you should write 2 over x squared. I think we understood that one in the previous part. Okay, then root of x squared is equal to what? Root of x squared, normally it's equal to absolute value of x. With respect to the x value, we should decide about the sign. If the x sign is positive, we are taking a positive out. If the x sign is negative, we are taking negative out. So this is going to be equal to limit x tends to infinity, x times 2 plus 4 over x over absolute value of x times root of 9 plus 2 over x squared it's going to be. And I try to explain absolute value of x should be positive, so you should take with the plus sign limit x tends to infinity x times 2 plus 4 over x over x times root of 9 plus 2 over x squared. It must be. When you simplify this two, you finish the infinity over infinity part. That's why you finish the infinity over infinity part. That's why you can replace the infinity on this part. 2 plus 4 over infinity over root of 9 plus 2 over infinity squared. This is equal to 0 and this is equal to 0 it's going to be. Then 2 over root of 9, that's equal to 2 over 3. We can apply the same rule to this one. This one will be homework for us. Okay, now 2 over q to the power of x, 2 to the power of infinity, 2 to the power of infinity is going to be equal to infinity. As also same for the 5 to the power of x also, that's also infinity. Infinity plus infinity is infinity, infinity plus infinity, infinity, so it is equal to infinity over infinity case. What we are going to do here, limit x tends to infinity, 2 to the power of which one has the greatest base, we are going to take greatest base parenthesis. So it's going to be equal to 2 to the power of x over 5 to the power of x plus 5 to the power of x over 5 to the power of plus 1 over 5 to the power of x. Okay, numerator is okay. Now for the denominator, the 5 to the power of x parenthesis I got, then 3 to the power of x plus, 3 to the power of x over 5 to the power of x plus, when you get 5 to the power of x here, you took everything, that's why you need to leave 1. Here 5 to the power of x, 5 to the power of x, we simplified. Now we should try to understand what is 2 over 5 to the power of x when you apply. 2 over 5 to the power of x, infinity is equal to what? Normally this expression, when the value is increasing, for the rational number which is between 0 and 1, the value it's getting closer to 0. What I mean? 2 over 5. This is 0.2, it's going to be 0.4, it's going to be, sorry. The square of this number, which is equal to 4 over 25, that's equal to 0.16, which is smaller than with respect to 0.1 approximately, which is very close to 0. Or when you get here, when you get the square of this one, or the third power of it, third power, it's going to be equal to 8 over 125, and it's going to be equal to 0.064, which is a very small number. As you see, when you continue to increase the power, the number is getting closer to 0. So when you go to infinity for these numbers, the result is going to be equal to 0. And 5 to the power of x plus 1, it's going to be equal to 5 to the power of x and 5 to the power of x. We simplify. We have 5 to the power of 1 here over 3 to the power of x over 5 to the power of x. It's going to be equal to 3 over 5 to the power of x, which is also equal to 0, plus 1 here. The answer is going to be equal to 5. I think I need to explain here. 5 to the power of x plus 1 is equal to 5 to the power of x times 5. And that's why when you simplify by 5 to the power of x, this one you simplified, and you left here 1. Now for each type of question, we have different solution methods. Here, when you apply the 0, cotangent 0, it's going to be cotangent 0 is infinity, cotangent 3 times 0, this is also infinity, this is infinity over infinity case again. So what we are going to do here in this type of questions, we are going to apply trigonometric transformations, which is trigonometric identities also. Limit x tends to, we know, cotangent 2x is equal to 1 over tangent 2x. This is trigonometric identity. So instead of this one, I'm going to write, instead of cotangent 2x, limit x tends to infinity, limit x tends to 0, 1 over tangent 2x over 1 over tangent 3x it must be, and this is equal to limit x tends to 0. This tangent x goes up, this tangent to x goes down, then it becomes tangent 3x over tangent 2x. Now this is 0 over 0 case, because tangent 3x, 3 times 0, 0 over 0, and this is the trigonometric 0 over 0 trigonometric form. That's why we are going to apply the formula. The formula says the coefficients of the x's. The answer is going to be equal to 3 over 2. You remember from the previous video. Okay, here we have tangent x. Tangent pi over 2 is infinity. Pi over 2 minus pi over 2 0. Cotangent 0 is equal to infinity. And this is infinity over infinity case. But here we are going to apply one transformation. We can write like this. Cotangent, we know the reduction formula, cotangent pi over 2 minus alpha is equal to cotangent, minus tangent alpha. We know this one, cotangent pi over 2 minus alpha, it's equal to tangent alpha. And cotangent minus pi over 2 minus x is going to be equal to minus cotangent pi over 2 minus x, and it's equal to minus cotangent x, minus tangent x. Minus tangent x is going to be. Okay, what about minus tangent x? Cotangent minus alpha, cotangent minus alpha, it was equal to minus cotangent alpha. So this minus sign can be taken out. Okay, then I'm rewriting the expression here one more time. Limit x tends to pi over 2 tangent x over cotangent x minus pi over 2. X minus pi over 2, it's going to be minus pi over 2 minus x, that's equal to minus tangent x. If you simplify this 2, this is going to be limit x tends to pi over 2 minus 1, and this is going to be constant, and the answer is going to be equal to minus 1.